Okay then. Last session we start to talk about some of the laws that we use for analyzing a circuit, and later on we are going to use them. So mainly we focused on the Kirchhoff laws, the Kirchhoff current laws, which would say that all the currents enter nodes should leave that node. So in other words, the net current goes in and out of the nodes should be zero. And the second one was the Kirchhoff voltage law, which says that if we choose any loop in a circuit, if we add all the voltage in that circuit, it should be zero. It should come out zero. And then we started to talk about the elements in the circuit, and the very first thing we talked about was the wire. So if we have the wire in the system, basically the only thing about the wire is important is that if it's a short circuit or open circuit, we should talk about them probably later in the semester. Otherwise, wires just connect elements together, doesn't do much about that, so don't need to be worried about that. And also we talk about a little bit about series and parallel circuits. Today, first I'm going to talk about a couple of more elements in the circuit, and then one important laws, which is the Ohm laws, and we use that a lot as well. One of the other, if you have any circuit and then we want to, let's say, for any kind of circuit that we have, the circuit should have the source. We need to have a source of energy. So if you have a circuit and want everything that work, we need to have the source. Like, well, for example, when you have your phone, should have a battery. So it should provide that it's a source of energy for your phone. So it should gives the energy, and then all the elements in your phone starts to work. So we need to have the source, and we have two types of sources. It's going to be the voltage source, and it's going to be current source in general. So when we are talking about, so we have the sources. And then the sources are like that. So we have source. We have two types of source. So we have voltage source, and we have a current source. Which the voltage source provide, and it's like the battery we have, it provide the specific voltage to the system, and the current source provide a specific current into the system. In most cases that we are working, we work with the voltage source. In some cases, we work with the current source, but in this course, mostly we focus on the voltage source. And then either of these two can be dependent or independent. So it can be sorry, let's first start with independent. So it can be independent source or it can be dependent. The same here, it can be independent or it can be dependent. And it means that when we talk about it is independent, it means that regardless of what we have in our circuit, it gives us very specific voltage. For example, if we have a battery of 3 volts, it always gives us 3 volts, regardless of what we have in the circuit. It's always 3 volts. Some of the systems are like that. It depends on other elements in the amount of energy they are going to provide depends on what other elements we have in the circuit. So it might provide 1 volt, it might provide 2 volts, it might provide 3 volts, depending on how the other elements in the systems behave. So those are going to be dependent. The same also for the current source. I'm gonna just look into them. So the um, very first one that we will look into that is the uh, independent voltage uh, and then and voltage source. The independent voltage source. When we are talking about again, so is the voltage source that is not depend on any element in the system, and usually when we are talking about the independent, we use just the circle to show that. So it would be something like that. For example, we would say we have, for example, a voltage system like that, and assume, for example, it's a 12 volt, like the battery car. So we know that is the uh, independent, no matter what we are going to connect to these two ends, is always 12 volts. It can be also the alternative format. So for example, it might be similar like that. So it, again, it's going to be positive, negative, and then for example, the voltage can be what is, so for example, it's going to be, for example, 2 cosine pi t. So it means that it's just goes ups and down, positive and negative. So it's as we said, it's changing, but it is independent. So it's a voltage source and it's independent, regardless of what we connect to these two ends of this battery. It always gives us it always gives us this value. Doesn't matter what we are gonna connect to that. So this is the independent one. Then we have the dependent voltage source. And usually we show the dependent source like this. So if, for example, usually show it like that. And then it says, okay, it's a positive, it's a negative, and then assume it's connected to an element. Like that. And then that element has the voltage of Vx. Usually this one is going to be, for example, like that. So assume, for example, here is going to be 2 Vx. So depend on when we have it, depend on what's going to be the voltage in that element. This source is going to provide us 2 times of the voltage that's going to be in that element. So if that element somehow changes, if the voltage in that element changes, the voltage this source is going to be providing is going to change as well. So the value this source is going to give us is exactly depend on how much voltage we are going to have in this element. Look at here, is not the case for this one. In this one, regardless of what we are going to connect to those ends of that source, it always gives us 12 volts. No matter what I'm going to connect to that two ends. But here, it depends on what I'm going to connect to that two ends. Depending on what we have here, this one's going to change. And it might be, it's very simple like that, or you might have, for example, more complicated system, and for example, you might have something like that again. And then you have a couple of elements in the system. Something like that. It's going to be positive, negative. And this time, for example, assume this one, for example, is the Vx. And then this one, for example, is going to be 5Vx. So the values this one is going to provide you, it depends on the voltage value we have in this element. So it might be depend on this one or any other element into the system. So regardless of that, if your voltage source depends on any element, so whatever is going to provide depends on elements, any elements in the system, it's going to be dependent. If not, it's like that, like the car battery. Regardless of what you are connected to, that is always give you 12 volts. It's going to be independent source. And these two are, so what we have here, these two are the voltage source. It's very same as if we go ahead for the current source as well. So we would have the independent current source, which again provide the current in the system regardless of what is connected to that. And again, similar to that, for the independent, we show them with the circle. And if it's a battery, we show plus minus here. So we put plus and minus. If you have put plus and minus, it means it's a battery. It is a voltage source. If you put the arrow, it means that it is a current source. And the direction of the arrow shows that which direction is going to provide the current for us. For example, assume this is 2 amp. So it means that this source, regardless of what I'm going to connect to these two ends of that source, always provide 2 amp of current into the system. The same as before, it can't be alternative. So it might be, so example like that again. And for example, again, it can be, for example, 2 sine, for example, 2 pi t. 2 pi t. So it might be alternative. Again, regardless of what I connect to those ends of this source, is always this is the value it's going to provide us. So it is independent of what is going to be connected to that source. Similar to what we had before, for the voltage, we can have the dependent current source. So the dependent current source also is going to be depend on what we have, and as I said, it's going to be shown like this. So whenever we have it like that, it's going to be shows dependent. And if, for example, we have assume 2, let's say, elements here, and this one, for example, we have the current, and it might be sometimes, for example, here you might have, let's say, assume it can be Vx, and for example, the current in that it might, let's put it the other way so it's easier. Assume the current here, let's put another one. Now assume the current here is I, and then, for example, here you might have, you go there and say, if this is Ix here, I have 2Ix. So whatever current you have here, you might have that current here as well. Well, one other thing is that for the dependent sources, it's not, here we have the I and I. It might be depend on the voltage or the let me draw. For example, it can be like that. So for both of them, so for current, it might be like that. So it's going to be something like that. And then, for example, it says that if this is the Vx here we have, the current, for example, is going to be 3Vx. So don't get confused. So it is the current. Still, it is a current, but it is 3 times of the voltage. So whatever voltage value you have here, the current is dependent on the voltage. Here, the current is dependent on the current. in another part of the system. Here the current is depend on the another current, let's say voltage rather than the current. It can be the same as for the voltage as well. For example, if here I was talking about this, here also it might be, we might have another one that says that instead of rather having, for example, this is positive, negative, and then go ahead, something like that. And for example, if this is the IX, then come here and say the voltage, for example, here is 2IX, for example. So still it is the dependent voltage source, but rather than depend on the voltage in another element, it can be depend on the current in another element. So it can be both ways. So when we have here the dependent, this voltage might be depend on the voltage, or the voltage might depend on the current in another element. The same as when we come here, the same as here. Also, the current might be dependent on the current in another element, or it might be depend on the voltage in another element. And we use them. But in most cases, but we are working with, for majority of cases, we work with the simple battery, just the independent voltage source, like a battery. And we are using some of these, but not that much. So the very next one, which is a very important law that we are going to talk about, is the Ohm Law. The Ohm Law is saying that, and this is another law that we use it a lot, that if we have a resistor in the system, and the resistor, it's, for example, if you have those, look at those old lamps, so that element, that filament in the lamp is the resistor that it heated and produced the light. Or if you have the electric stove, everything to have that generate a heat out of the electricity is just a resistor. So if you have a resistor in the system, like the toaster, so you have a toaster, you turn it on, then it heats and toasts the bread. It says that if you have that, and then it's going to be positive here, negative here, and then the voltage in this resistor is V, and the resistance here is R, and then the current goes through is I. It says that V is always equal to I times R. And this is the Ohm law, and we use it a lot throughout the courses. So make sure that you remember that if one equation I want to memorize, it would be this one, because we are using it a lot. And it's very important to know how to work with that. Generally, it says that the current and the voltage in the system, the voltage and current in the resistor, it depends on this constant value of the resistance here. So if, for example, this is how these two are going to be connected. So if you have the, for example, the constant voltage source, like the battery, if you keep increasing the resistance, the current goes through, keeps dropping and dropping and dropping. If eventually you increase the resistance so high, there's no current can go through, almost no current can go through the circuit anymore. So it's a very simple equation in form, but we will use them a lot. couple of points that I want you to remember. The most important point is that in resistance, always current goes from positive to negative polarities. It is very important. Later on, we will need to know that always is like that. Always current goes from positive to negative. Always. So if we have if we know the sign, if we know the polarities, if we know it's positive, it's negative, so I is always goes from positive to negative. If we know I goes from this direction, so always this head is going to be positive, the other end is going to be negative. So these two is always like that. Remember, it's only for the resistance, so not other elements, but for the resistance, which is the majority of work we are going to do is the resistance. Remember, that is always like that. The current goes from the positive end of resistance to the negative end of the resistance. Okay, there are two other, we're not going to use them, but since it's the book, I just mentioned them. Two other, I would say, concept that you know that one of them is the conductance. Just know that the conductance is, we show it with the G, and just 1 over R. Just know that it's the inverse of the resistance. So if you have the V is equal to IR, and then if you rearrange it, write it as the R is 1, oh sorry, rearrange, just say I is 1 over R V, you can say that I is G times V. So just remember, just know that it is 1 over R. We actually don't use it. But if you heard the name somewhere, just know what it is. The other one is how do we calculate the resistance in simple wire, or what's the resistance of the simple wire. For example, I want to say the wire here because I don't want to get confused, but how to calculate the resistance of the wire. So the resistance of the wire, the R, physically, it tells how physically you calculate that value. The physically is going to be rho L divided by A. So if you have a piece of wire like that, and it has a cross section of A, so A is cross section, and it has a length of L, and the rho is the physical constant. So they call it resistivity. Yeah, resistivity value. So is it? This is a resistive. It's a physical constant, and it depends on the material you are using, and it changes from different material. For example, for the copper is 1.72 times 10 to the negative 8, for example, for copper. That rho is equal to 1.72 times. So as you see, it's a very small value. So that's why the copper used for wiring, because it has a very low resistance for the current. But for example, if you, for the glass, for example, the glass almost doesn't let any current goes through it. So it's going to be 1 times 10 to 12. So this is the constant, depend on what material you have. So if you have the cross section of the wire, you have the length of the wire, and then this is the physical constant, you can get how much resistance you will have. And by the way, the resistance is shown with, it's called the Ohm law. The resistance itself is also in Ohm. So what's they called? What's the resistance? For example, they say the units of that is Ohm, and showing with this sign, which is the Greek omega letter. So this is how they show the resistance units. Remember, the resistance is and it's the O. So it's the symbol they use it to showing, and its name is O. So for example, they said, what's the resistance of that resistance? So you know how it's given with the O for that. And then the very last things also for is the power in the resistance. And as I said, the power is always the power is always P is VI. It's always like that. And then we know that the V is also IR. So if you put these together, you may say you may present P as one of these three formats. So either you write it P is VI, or you write it as a P is equal to, P is equal to RI square, or P is equal to V divided by V square divided by R. So you can present P with, if you combine these two equations, you can get these two. But I usually suggest just remember this one, the very first one. So remember, this is the power formula, this is the Ohm formula. You can combine them to get these other two equations, but these two other equations is just combination of these two. I would just remember the P is equal to VI, the very top equation. Remember that the resistance always use the energy. So if you have a battery and the resistance, the battery can use the energy or can provide the energy. So if your battery giving the energy out, so provide the energy. If you're charging your battery use the energy. The resistance always use the energy. So it always absorb the energy. Because of that, the P, and remember, when we use the energy, P is positive. When we provide the energy, the power is negative. So for the resistance, power is always positive. It always using the energy. So power in the resistance is always positive. That just remember that when later on we are doing the calculation in the system, if somehow you see that you calculate the power for the resistance and it comes out negative, so you make mistakes somewhere. You have to go back and look at what's going on. So if you have the element, if element use energy, then P is positive. If element provide energy, then P is negative. So in most cases, the battery provides energy. So the power of the battery is negative, the power the battery has. In all cases that we have the resistor for use the energy. So in all cases that involves resistor, the resistor's power is positive, like the lamp. When you go and says that this lamp, for example, is 100 watts, it means that it always absorbs that much energy. The lamp does not provide any energy to you. It doesn't provide any, it just use the energy. Or the toaster, when it's open, says, for example, 1000 watts, it means that it used that much energy, and because the resistor. So remember, for the resistor is always positive because the resistor always just use the energy. It always absorb the energy. The battery, if provide the energy, it's going to be negative. The battery using the energy to get recharged is going to be positive. But this is the general rule. So if using the energy is positive, providing energy is negative. Because of that, the resistor is always the first case. Battery, most of the time, is the second case, unless we are recharging it. Okay, now I'm going to start talk about the circuit analysis, but I'm going to talk about a very simple circuit right now, just to give you some idea happening. And this is the very last section of the chapter 1. And then in the chapter 2, we start to actually focus on more complicated circuit, how to analyze the circuit to work on that. Okay, so let's start with a very simple circuit in our system. So it's going to be circuit analysis. So let's assume we have a very simple circuit like that. So we have a source that has a 10 volt, positive, negative, and then I have a resistor with 5 ohm. So assume this is the circuit I have, and when one says that we want to analyze the circuit, it means that we want to find the current and the voltage in all elements. So here, the only element, so the battery is the source, the only other element we have is the resistor. It means that if I tell you analyze this circuit, it means that go ahead and find the voltage and current in this resistor here. So the very first, let me do the very first step. So the very first step is just choose the I. Just assume the direction of I. I usually put the I going from negative to positive. So I would say that this is the I. And then I would say that I would choose I want to say that for loop 1, so that's the loop 1, I'm going to write the KVL. And I start from one node here. Any node you can choose, but I'm going to start from one node at the very lower corner here. So if I write the KVL, it says that sigma V is 0. So if I start from here, I first hit the negative sign. So it's going to be negative. Then it's going to be Vs. And if I keep rotating, I goes from this direction. Remember, I always goes from positive to negative. I always goes from positive to negative because I chose the I goes this way. So remember, the direction I chose might be wrong. It might be wrong, but I assume it is right. So if it goes from this direction, so this one should be positive, this one should be negative, because I always goes from positive to negative in resistance. So I come here, I hit the positive. So it's going to be positive. And if this is the V at R, let's say there's a VR here. So I have VR is 0. And then if you write this equation, the VR would comes out at 10 volt. So never waste your time on defining which direction should. In this case, it's very obvious because it goes from negative to positive, and the battery it goes like that. But in more complicated circuit, it might not be that obvious. If it's not obvious, don't worry about it. Just choose the direction of the eye. The only thing that you make you choose correctly is that eye is always goes from positive to negative. So if you choose the eye like that, make sure that you choose the positive and negative polarities according to the direction of the eye you choose. And don't just go ahead and when you solve the circuit, if everything comes out positive, means whatever you assumed is right. If anything comes out negative, it means that it's opposite of what you assumed. If the I is negative, means the direction is reversed. If the V comes out negative, means the polarities should be flipped. So to find the current goes through that element, the easiest way that you can do it is just use the Ohm law. The equation that we just used is the V is equal to IR. That's that for the resistance, we know that the voltage in the resistance is proportional to the current, the voltage and current in the resistance are proportional to the resistance value itself. So the next thing that you need to do is just go ahead and here say for in resistance, you can say that V is equal to IR. And the V here is the V for the R. Here is the voltage in the resistance. The R, you have it, and then you can get the I. So if you put the value here, for example, you have the 10 volt for the voltage, and then you have the I, and then you have the 5 for resistance. And then it's going to gives you the I is 2 amp. And then if you want, in case that you need it, if I ask you what's the power, for example, the resistance uses, you can just use the P is IV, and just says that the power in the system is the I, which is 2 amp times the voltage, which is 10, and say this resistor using 20 watts of power, if in case that you need to calculate that otherwise. And if this one is using 20 watts, it means that the battery is providing 20 watts. So if here we have the positive 20, the battery, the power in the battery is negative 20. So the battery provide that power that this resistance using. So here is going to be negative 20 watts provided by source, and then here is a positive 20 watts, which is used by the resistance. Okay, let's look at a little bit more complicated example about circuit analysis. So assume that I have a source like that, so positive, negative, and then I have the resistor. It's going to be, it's a positive, negative, Vx, and it's going to be Ix going through that. And it has a 10 ohm resistance. And then I have a dependent source sitting here, and it's going to be 0.5 Ix. So whatever Ix I have here is going to be 0.5 of that as the current source. And then I have another resistance here, which I have the Iy going through that. And it's going to be, again, it's a positive, negative. It's a 15 volt, and it is 5 ohm. So assume I have this circuit and I want to analyze this circuit. Yeah, that's all I have. So if I want to analyze this circuit, you look at it and see what you can get very first. So here, this is unknown, so I can't do anything here. Here also, the voltage and the current is unknown, so I can't do anything here. This one is also unknown because it depends on the Ix. So the only thing I might get something out of that is this one. So if I write for the resistance, so for resistance, if I write the Ohm law says that V is equal to I times R. So here the V is 15 volts, and the I is Iy, which is unknown. And then the R is 5 ohm. Let me put it a little bit here so it's, don't see it as a negative 5. So the 15 volt and 5 ohm. So times 5. So therefore, the I sub Y would comes out as 3 amp. If I write it like that, or from here, instead of writing amp, we just put the sign of that. So it's a 3 amp. So if I start from this resistor here, write the Ohm law for that, so I get the Iy is 3 amp. Now, the next step is that I have to go here. Either the other unknown is these three. Either I have to calculate Vs, Ix, or Vx. I have to find one of these three. If I look at here, so the Vs probably I cannot find it right now. The Vx, I can't find it. But the Ix, I might. So if I come here and look at these top nodes here, these nodes here, I call it, for example, the node, let's put it 1, for example. If I write in this node, if I write the KCL, Kirchhoff current law, at 1, Kirchhoff current law says that all the I should be 0. If I add all the I going through that node should be 0. So what are the I have in that node? So I know that the Ix is the Ix going through that. So that's the same Ix going through that node. Also, I know from the direction of this arrow, I know that half of Ix is also going through that node. And from that Iy, I know that the Iy is leaving that node. So Ix coming in, half of Ix coming in, and Iy leaving out. So therefore, I would say the Ix, black. So I would say the Ix going in is positive. The half of Ix going in is going to be also positive. and the IY leaving, so it's going to be negative. Again, this is the way I choose to use it. Anything enters, I consider it as positive. Anything leaves, I consider it as negative. So then I have 1.5 Ix minus, and the Iy, I have it here minus 3, is going to be 0. Therefore, the I sub x is going to be 2. So I think it's going to be 2 amp, if I write. So now I have the Ix. So now that I have Ix and I have the resistance here, I can write the Ohm law for this resistance. So again, if I write the for top resistance, I can write the again the Ohm law, and the Ohm law says that V is equal to IR here, and the voltage is Vx. We don't know what it is, and the I is the Ix, and the R is 10 ohm. Then the Vx, the Ix is 2 amp. We know it from the previous step, times 10. So it's going to be, comes out 20 volts. So it's a Vx that we have here for this case. And now the only thing left is this, find the voltage at this source. So if I want to voltage, I have also 3 rules. It's the KVL, KCL, and Ohm law. The KCL, we write it for the current, so it's not going to help us to find the voltage here. The Ohm law is only for the resistor, so we can't use it also here. The only thing left is the KVL, the Kirchhoff voltage law. So if I want to use that to find the voltage here, what the Kirchhoff voltage law says, that the Kirchhoff voltage law says that if I choose a loop and go through that loop, add all the voltage together, it's gonna comes out 0. So if I add all the voltage, then it should be 0. When I want to choose the loop, which loop I have to choose a loop that the Vs is in that loop. So I can either choose this loop, or I can choose the outer loop. The problem with this loop is that I know the voltage here, but I don't know the voltage here. I don't know how much the voltage is in this dependent current source. So if I choose this left loop, I would have a problem because I don't know the voltage here. So I prevent this loop. The other loop that includes Vs is the very outer loop. If I go to the very outer loop, this voltage I don't know, the voltage here I know, the voltage here I know, so I have only one unknown and I can find the voltage. So to do that, because of that, I will choose the loop at the very outer part of the circuit as that, and call it, so that in the, so if I write the KVL at outer loop, it says that all the voltage, if I add all the voltage together, it should come at 0. So I have to choose a point and start to rotate. So like always, I choose this node here. Any other node you can choose, but I choose this node here and I start to rotate. So if I start to rotate, it comes out, I first see the negative sign, so it's going to be negative. Then it's the Vs, the magnitude. Then it keeps going. I first see the positive sign here, so it's going to put the positive. And then I have the Vx here. If I go at the outer loop, then I hit here. Again, I first hit the positive, so it's going to be positive. And then the voltage, the value is the 15. And then if I keep going back, I reach the original point I start. So it's going to be 0. So then negative Vs, and I know the Vx is 20 volts. So I just substitute that. 20 plus 15 is 0. And then the Vs should comes out as 5. If I did everything right, is 35 volts. So now you can see that I have current and voltage, all the current and voltage I was looking for, the Vs, Ix, and Vx, and Iy. So I can just simply by using this law, I can use them. The only trick is that, and there's no rule, you have to yourself to get used to that, is that you have to figure out which law you use first, and then it follows what which law, and then follows with what which law, and then follows with what law. You know, it's not that hard as soon as you know which law you're using. Probably the only difficult part is that which one you use first, which one used second, which law used third, and so on and so forth. And when you start practicing, you will get how to. So it's not that difficult. Probably at the beginning it might seem a little confusing, but after you start practicing, you will figure out, okay, this is the first. This is the law I should first. This is the law I should second, and so on. Okay, up to here, that's the end of chapter 1. So we have the chapter 1 is finished, and basically in chapter 1, what we learned is that what's the basic elements in the circuits, and one of the what are the basic laws that we can use to analyze the circuit. From the chapter 2, as we are going to start to move to circuit which only has the resistance. So we look at how, if we have a circuit that only has this battery, or it only has a source and only has the resistance, then how we can start to analyze that.